Oh, okay. Um, oh, okay. I don't know if it's streaming right now. Let me just check my phone. Uh, hmm. Okay, it's working. I think that's fine. Hello, hello. Um, yeah. So I'm applying for this job. Over here. Um, I said there's an internship challenge, making an LLM in a virtual world, and I just want to stream that so that I can I don't know how to say it, so that I can. Oh Jesus Christ! Oh, I want to stream it so that I can share my thought process and all of that, and I can get the video so that I can edit it later on. Let's start with a drawing of what I think I want to do. Math topics I should learn. This is, what was this again? I'll just delete. I haven't opened this. Mostly it's on my Windows that I do this, but I don't think anyone cares about that. New drawing. Okay. Thanks, I guess. I want to draw. Okay. So, the first thing I want to do is like the kind of idea that I'm thinking of, because you're saying I should create something that what do you call it? I should create something that, like a virtual world, and put the LLM inside, and there's a specific task that it could do. Um, so my idea was to make a a tic tac toe game, an infinite tic tac toe game. So the LLM is playing against. Actually, I had two ideas. The first one was the tic tac toe game, an infinite tic tac toe game, where the LLM is playing against, I think, a min max algorithm, and obviously the min max algorithm, I think, would honestly like beat the LLM, but the task of the LLM is just to survive. So you can switch. You can. I think I would make it so that you can switch the LLM to test it out, but I think mostly to just be a local LLM, and that would use Rust, because I've actually made a Rust implementation of that, but just on the terminal. But I never actually made the min max. Is it mini max? Min max. Um, yeah, min max. So wow, where is my okay min max algorithm? Anywho, so pretty much this written in Rust, and you connect it to the LLM, which would be in Python. So it would send the data to the LLM. That the LLM will send it the data back to the Rust stuff. Honestly, you could just write the entire thing in Python, but I want to challenge myself a bit. So yeah, that's just the idea. Anywho, Um, mm, I want to share the code that I did before now, written in Rust. Honestly, I was learning Rust at the time, so my thoughts right now may be a bit, or my thinking right now may be a bit as it projects. This is my Windows. Where is it? Where are my projects? Also, I haven't used KD Plasma before. I mean, this entire interface, because I was using Hyperland before, and now every single time I open this, I am quite confused. I mean, it's not bad. Okay, here it is. It's not bad, but like it's still in learning curve for me. Okay, here it is. It's a mini Rust implementation. Now I have to figure out how to um, write the Rust. I'll delete this. Okay, main. I've forgotten how to run Rust. I think it's Rust C. Yeah, there it is. Rust C main. Rust C main. The file in the directory. Where am I? Oh, what is the problem right now? The function. What? Wow, when I'm trying to run this right now, and I can't. It's so sad. Where is it? Line 17. You're trying to build a new hash map. Consider one of the following. Hash map new. Ugh. No function or associated function named this in the current scope. What do they mean by that? We're going to be doing some googling. Oh, okay. I seem like just a child going through the entirety of this. Line 17. Like this. It's a hash map containing an unsigned integer of 32 and a hash map of an unsigned integer of 32. Wait, what? Isn't this wrong? Aren't these both? Maybe I'd have added comments into this before I left. You know what? I'll cheat right now. I would cheat. I don't remember Rust, so I mean, they're probably just saying it down here, so but I don't remember how Rust works. From it's not even here. The error is because this needs to be called var from ether thread, not directly on HashMap. The simple fix is to use the collect instead or just call the HashMap from, which works directly with Rust. HashMap wants to stabilize this thing. I swear this was working before. Alternatively, you want to keep this, you can bring this straight into this thing. Or was it updated recently? No, not Rust. $9 old. I don't know. I'll just take it as it is. Where is it? From. Right. Okay. What? Or is this something about cargo? Oh, here it is. Never mind. So it just... There it is. Okay, there we go. I'll just increase this. So here is the kind of environment that I want. Sorry, it took too long. But here's the kind of environment that I want. Player 1 puts in like 0. Shit. Never mind. Why is it not working? Oh my god, this is so embarrassing. This is so embarrassing. I'm very, very certain that... Why is it not working? You know what? Let's just forget about like this. Let's just create a totally different one so that I can understand what I'm doing while I'm building it. Anyhow, let's continue with what I was talking about before. Okay, so the first stuff that I was trying to make was or the first idea that I had was the tic-tac-toe stuff where the LLM is playing again a mini-max algorithm. Its goal is just to survive different stages of the... Like, it's just... The goal of it is just to survive. The second one, so I'll just do... First idea, draw less tic-tac-toe with wow, it's not wrapping inside. Interesting. Tic-tac-toe. Yeah, draw less tic-tac-toe. That's the first idea. Let's design this a little bit. There it is. This is the first idea. The second idea was so everybody knows this guy. His name is Conway. I think that's how to spell his name. Conway's Game of Life. Conway. Never mind. Conway. Conway Game of Life. Survival. Wow, I love survival so much. So there would be the goal would just be to survive in that environment. I actually got this idea from because I was interested in implementing this, but I actually got this idea from a game. It's called Yonak. It's a pretty good game. I can just show that for some reason. You walk, I think. Yo walk. Steam. Yeah. Yonok. Oh my god, I don't even know how to say it very well. But it uses that. Yeah, it's pretty cool. I think it's pretty cool. Yeah, you see, it's how it's moving. Some of these are like stable states in their automatons, whatever. So John Conway's Game of Life. So the goal is just to survive over there. Yeah. But at the end of the day, I'm just going to choose the easier one to implement, and I think the easier one is just this one. To be honest, like, why wouldn't I do that? So this is gone. So what are the steps of me to do this? The first one I'm thinking about is like the first thing I'm thinking about is like a how do you call it? The first is to create the UI. So and I will be using Rust. Why am I using Rust? Honestly, just to soften myself, because wow, why is it doing like that? Why can't I just drag it down? So weird. Okay, there it is. So create the UI of an environment using Rust. Why am I using Rust? Because I want to get more knowledge of Rust. I've been picking up like programming languages recently, and programming languages recently, and Rust is one of them. The other one is C Sharp. It's for another project that I am working on. Anywho, so first is just to create the UI. And what would I be using to create the UI? It's something called Rust's UI, I think. No, not this. It's a terminal. Rust terminal UI. Yes, this. Why am I using this? Cause it looks cool. Maybe I wouldn't be able to use this, but yeah, it gives more like visualization as to how it is. So you just watch me learn all this on stream. But yeah, I'll be using this. Once I'm done with the UI of everything, I should probably add something over here. Was it Ratatouille? I think I get where they got that stuff from. Okay, that is the first step. The second step is actually to the second step would be to create the mini max algo for the game, so that at least I have the something to play against. Wow, this is horrible. Something to play against. So create mini max algorithm for the game. The third thing would be to actually connect sending data to the Python. So like send the data of the game to Python for the LLM. Now I don't know how it would work, to be honest, like how the data will be represented for the LLM. I'm thinking that it would just look like how it is over here, so that the LLM would just know. I don't know whether that is the greatest thing to be using, to be honest, because how the game works is you do X, let's say they are 3, so they have to be more than 2 spaces left. So if you do X O X O, immediately you put the next X, the previous X or the first X would disappear. So you have to somehow represent that as a kind of a good amount of data that the LLM would be able to understand. Okay. I don't even know whether I'm saying all this right, but my explanation is so. I mean, at the end of the day, I would still edit the entirety of this if I'm doing it for a video. So alright, there it is. So this is just the game plan of everything. So to start, I have to actually make the UI of the game, and that is what I am going to do. How do I do this? Is it over here? Oh. What should I even name it? I don't even know what to name it. What do I name it? Survive. Is that how to spell arena? Yeah, it is. Okay, never mind. Okay, and then we just open the terminal here and do code. Now, we're starting with Rust. I don't know anything about Rust. I've not coded in Rust. Like I know things about Rust, but I haven't coded in Rust in a long time. So you guys will have to bear with me while I am going through the Rust Bible, because that is what it's called. I should probably call this like learning Rust or something. Oh well. I haven't closed it. God damn it. Um. Oh, this is cool. All right. I've gone through this before, so I should already have. I should be able to. Using cargo. I have cargo already. I should really learn the shortcuts of this. How long is this again? Wow. I should be fine. It should be fine. How much? 20. Oh, 22. I'll just speed run through all of them. Let's get started. Print hello world. There's a cargo command for this. Yeah, there it is. Here it is. Okay. You just see the into it. We can run that. And hello world. There you go. This cargo build. Now let's take a difference between where you run hello world with cargo from a garage where you build it. What's the difference? Cargo man blah 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 blah. I'll just reprint hello world. We run the project to that. Using cargo run is more convenient than having to do cargo build. Okay. Cargo check. Check your code to make sure it compiles but doesn't produce any executable. Often, cargo child is much faster than cargo build because it skips the code of producing the execution. If you're continually checking your work while writing your code, use child check will speed up the process. Let you know that. So, process of letting you know that. Additionally, the use of cargo commands are the same no matter what operating system. So at this point, we now get specific to okay. I wanted to go play Deadlock, but I think I'm not going to be doing that right now. Create a new game, maybe it guess. Okay, I can do that. You know, I would have just. I think I know what to do. I'll create a new folder inside here. And I'll call it there we go. I should also change the stream to that. No, not from here. I don't even know whether this is. I know how a live stream works. This should close. I'm gonna change it to learning Rust. Okay. What's the shortcut to this? Ah, that's long. Now let me see whether I can remember that. It's Control Shift Plus? Never mind. It is Control Shift. No, it's not plus. Okay, cargo guessing. Cargo new. Clear that. We enter inside it. Do I even need to? I can run cargo from here. Can you put multiple cargos in one file? You know, maybe it wouldn't be bad. Wait, let me see something. I can just test it out. Okay, if I do like cargo build, which one would it target? Oh, I have to be in the file. And if I do cargo build inside here, it should run that. Okay, that works. That's fine. That's good. That's really good. Okay, never mind then. I'm just going to delete this. So it's kind of like UV, no? I mean UV is written in Rust, so UV is written in Rust, so that's fine. Setting up the project, guessing game 1.1, blah blah blah. The first part of the guessing game is process check the input to start. We allow the player to enter the code. Enter the code in this. Oh, you can run and debug from here. Is this new? Feels new. Can I pause the live stream? I wanna eat. I'm so hungry. I actually need to go out and buy. Buy some materials to cook some food. To start, we allow the player input. By default, Rust is standard library, standard code. You can see everything in the standard library documentation. I'll look at it later. To obtain the user input and print it to user output. Print line, let's it's mutable, right? Yeah, it's mutable. So it can change. Then they're using the standard library to read. This is a pointer to the guess, and they're doing an accept like in Python, and doing all that. Okay. Yeah, it's a reference or a pointer. There's something that confuses me about this, which would be later down the line over here. I think it's here. When I reach there, you would see it, but pointers are really confusing. Sometimes I wish I don't even like. What? No. Oh, I haven't saved this. Okay, so it's guess the number, put in your guess. It doesn't actually use any random stuff. So It's just doing guess one. Understandable. By default, this is a preload. You can see everything here. If it is a type that isn't a preload, you have to bring it into the scope by using the use statement. The use of this provides you with a number of useful features, including the ability to accept user input. As we saw in chapter 1, user function, everything. The FN syntax is to declare a new function, parentheses to integrate there is no parentheses. It's like Python. I've never actually interesting. You know what, let's install these. Yeah, trust. What does this even mean? Is it showing me an assembly? Oh, I don't wanna. I think I'll just use this instead. Oh, never mind. I'm already in there. Use the let search for to create this thing. Here's another now. This line creates a new variable iter and binds it to the number 5. In Rust, the variables are immutable by default. And once we give the variables a value, the value wouldn't change. We'll be discussing this concept in chapter 3. To make it mutable, we add the mutable stuff. This is a comment, it's in every language. The equal sign tells Rust to bind it to something. The dot syntax, or colon syntax, is even a colon? I don't know if it's a colon. The colon syntax indicates that the line is associated with a function type string. Associate function, in this case string. The new function creates a new empty string. You find the new function on many types because it's a common name for a function that has a new value of some kind, that makes a new value of some kind. Recall that we included the input-output functionality from the standard library. What else? The full job of readline is to take in whatever the user types into the this thing and append it into a string. Sorry, what? And append that into a string without overwriting its content. We therefore pass a string as an argument. The string argument needs to be mutable so that the method can be changed. So that the method can change the string content. The answer indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy the data into memory multiple times. Reference are a complex feature. One of Rust's major advantages is how safe and easy to use reference. You don't need to know a lot for this one. Hence, yeah, it's in 4. Hence, you need to write this rather than this to make it mutable. Okay, that's fine. Since we're working in this line of code, one long line is difficult to read. The best is to divide it. As mentioned earlier, the read line puts whatever the user enters into a string we pass to it, but also has a result value. The result is an enumeration, also called an enum, which is a type that can be one of multiple possible states. The purpose of this result type is to encode an error handling message. Results variants are OK and error. The OK variant indicates the operation was successful, and it contains the successfully generated value. The error variant means that the operation failed, and it contains information about how or why the operation failed. The values of this thing have methods defining them, and instead of value, if you don't call the set, the program will compile, but you get a warning. The result may be an error variant which should be handled. Rust warns if you haven't used the result value returned from read line, indicating that the program hasn't handled a possible error. Write a way to suppress the errors. You'll learn more about this in chapter 9. Learn more about that in chapter 9. We get some food. Maybe I should also start streaming on Twitch. That would be cool. £52. That's bad. That's not bad. Mm. Honestly, I've just been eating burgers like recently. I'll just go buy a £5 burger or something. 99k. Buy a £5 burger and then just gulp it down. Is that weird? I don't know. Let's see. Okay. Did it send the money back to me? It's fine. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game will be fun more than once. We use a random number between 9 and 100 so that the game isn't difficult. Rust doesn't yet include a random number function in the standard library. Cool. However, the Rust team does provide a random crate with that functionality. Remember that a crate is a collection of Python code. The project we've been building is a binary crate, which is an executable. What? The project we've been building is a binary crate, which is an executable. The random crate is a library which contains the code that is intended to be used in other projects. In other programs that can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines, because before we can write the code that uses run, we need to modify the Tom file. Probably just specifier. This is a shorthand for this, which means any version that is at least this but below this. Cargo considers these versions to have public APIs compatible with this, and this specification ensures that you get the latest patch update that will still compile with the code in this chapter. Any version this and that is not guaranteed to have the same API. Now, without building the code, without changing the code, let's build it. Okay. Oh, I just typed that out. Never mind. Never mind. These great people, they take £2 from sending, which is more than wise. Uh, so they eat the money from converting and whatever, man. It's building, let's go. Okay. You may see different version numbers, blah blah blah. When we included this after registering, immediately you run this without making any change. You see, when you open make a trivial change, then save it. You only see 2 lines of code. When you do it, it's a and to ignore the thing and figure out all the latest versions. Cool. First, it generates the secret number. Does it run thread, run RNG? Does it? Okay. First, we add the line RNG. The RNG defines the trait method that the random number implements, and this trait method must be in the scope for us to use. Chapter 10 will cover traits in details. Next, we add 2 lines in the middle. First, we call the run thread RNG function that gives us the particular random number generator we're going to use, one that is local to the current thread execution and is seeded by the operating system. Then we call the GenRange method on the random number generator. This method is defined by run thread that we bought into the scope using rand save antigen, takes in a range of expression range expression into as an argument and generates a random number in the range. The kind of range expression we take here is from start dot 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 equal end. That's the 1 to 100. And it's inclusive in the lower and upper. So we need to specify. Why don't like every programming language use this? Python does, I think, when you're doing like a for loop, or is it for loops that's it? I don't think it's the for loop. There's one particular stuff where one is inclusive. It splits where the I think the first number is inclusive while the last is exclusive. So if you write something like let's say there was a list like 1, 2, 3, 4, and you do something like 0 to 2, 0, 1, 2. So it wouldn't include the 2. If I remember correctly, it would just be these 2. Let me confirm that, because it's been a bit long since I've used and I don't know why that is. Sorry, I don't know if that's a design choice. I think it's even in it's called slicing. So you're saying 0 to 3, it will only do 0, 1, 2. You're seeing it down here, 0, 1, 2, but you're doing 0 to 3. So the last one is exclusive, which is like, man, why don't they just make it inclusive? I don't get I don't get it. I don't get it at all. So this one we're now taking let me not even look at it. This one would now taking this like apple, but it will stop at apple lime. See, apple lime, which is like, why don't you just wait? Why didn't they just make it inclusive? So when you now switch to another language right now, like that's Rust, you have to start. That's fine. It's fine. It's fine. It's fine. I honestly don't know why they don't just make everything inclusive. It's weird. And it's inclusive in the upper bound specified to this. Note, you won't know the trace. You wouldn't know which traits to use and which method to use to call the function for the crate. So each crate has a documentation listing this. Another neat feature of Cargo is OpenDoc, which will open the code of all your dependencies. Oh, that's dependencies in your browser. That is really cool. It actually saves it. Where does it save it? Number guessing game that this. I think that's pretty cool. I wish Python had the same thing. Well, is it even possible in Python? I mean, it should be. And click on the random creating sidebar. You know, I'm taking some Dr. Pepper right now, and it's kind of eh. Okay, that's fine. Honestly, I'm talking to myself right now. There's no one actually watching. So sad, so sad, so sad. The second line prints the secret number. We can compare them. The step below. Note that this would not compile yet, as we will explain. First is an user analysis statement. You get ordering from the standard library. Then we add 5 new lines of code. The CMP method compares. It just means compare. Compares two values and can be called on anything that can be compared. It takes in the reference of whatever you want to. Reference of everything that you want to compare. Here it's comparing this, then it returns an order enum that we brought into the scope. We use match expression to decide what's the next thing to do based off of the variant of order that was returned from the call to the compare to the comp with blah blah blah. The match expression is made up of arms, and arm consists of it's just like switch in C#. And the code that will be run first takes in a given value to match and looks through each of the arms. The pattern and the arm constructs are most powerful. It lets you express a variety of situations that your code may encounter and makes sure that you can handle them all. This feature will be covered in detail in chapter 6 and chapter 19 respectively. Let's walk through an example with match expression. Say the user has 50 and the random, the same was 39. It compares this, and it compares that. Oh, the reason why is because this is a string. Yeah, so you have to convert it into a string. Into a just saying you have to convert it into a number. Trim is to trim the space or the enter key. Phrase is to We create a new variable named guess, but wait, doesn't the program already have a variable named guess? It does, but helpfully, Ross allows us to shadow the previous variable of guess with a new one. Shadowing lets you reuse the guess variable name rather than focusing on us creating two unique variables such as guess string and guess. So there's pointers and I think it just helps with memory safety, right? Like in Python, for example, honestly, Python, you can just switch it out and you'll be fine. You can even convert it there and there. Never mind. We'll call it more detail chapter 3, but for now, know that this feature is often used when you want to convert a value from one type to another. What's this? What was that? I don't know. I don't know what that was. The expression gas refers to the original gas that is contained at the input as a string. The trim method on this thing would eliminate any white spaces at the beginning, which we must do before we convert it to this, which can only contain numeric data. The user must press enter to safely satisfy the read line and input the guess, which adds a new line character to the string. For example, if the user types 5 and presses enter, the guess looks at this as 5 this, the end represents a new line, or Windows pressing N, the catch creates a new line. This the tree method eliminates this, which is return just 5. Interesting. Probably comment this out. Nice. Even though the space is red and this one do figure out the user is 76. The program running the program filter to verify the bits. But user can only make it one guess. Try a different loop. Try loop. want this to be an infinite loop. Here it is. I want to do this handling stuff. We switch from the let's make the game ignore the non-number so the user can continue guessing. We can do this by altering the line guess that is converting this to this as shown with this. Okay, num equals to num. But it's continuing. Weird. That's weird. The loop is enter a guess. Then it goes through the accept. Then it goes through the face stuff. That it matches it. We can switch from an accept to call match. What was the accept there for again? Oh, sorry. Okay. It didn't show please type in a number. Wait, no, I didn't build it. Oh no, the previous version did help that. Control Z. I want to see something first. Would it run the previous? Oh, it ran it again. So if I put, why isn't it showing the please type in a number? Well, it's not showing. Let's say I put in a symbol. Oh, okay, here it is. Please type in a number. Okay. Here it is. I wasn't just seeing it. Okay. The thing I want to understand is this num. We switch from excites to call match in match expression to move from crashing on an error to handling the error. So match can also be used to handle errors. Okay. Remember that the result type is an enum with OK and error. We use the match expression as we did in ordering the result. I want to check something for a sec. It returns a variant of an order name enum which we brought in. Oh, okay. It returns a version of this. So I'm guessing it's just referencing like if it is, I don't know how to explain it. How do I explain it? It's like it brings out either one of these. Like this comp brings out either one of these. At least that's how I see it. The occur variable is the first arm and the match will just return the number variable. It will go into It would return an error variable which contains the value, and the error variable does not match the distinct the pattern in the first arm, but it does match this underscore catches all the variables. In this example, we are saying we want to match all the variables no matter what the information is inside them. So the program will execute the second arm continue, which tells the program to go into the next iteration of the loop. So this would have crashed over here, but it's telling it to continue the loop. So effectively the program ignores all the errors the phrase might encounter. Okay. I wonder if I could increment something on top of there to check if like it reaches this particular amount of numbers. How long have I even been streaming for? If it reaches some particular amount of number, we stop the stuff and we break the loop. Too big. Okay. So what I want to do now is make an if statement in this loop. So it has to be down here or something. I'll create a stop doing this. Reject. No. It's mutable. Mutable chances equals to we can just keep minusing it. Stop doing this. We can just keep subtracting this. This is actually correct. And the chance is -1. I should really turn off that AI stuff because I'm trying to learn right now, and so the chances is equal to this, and we are going through it. We also need to it's too small. Chances remaining. Chances. There we go. Yeah. Inputs 10. It's between 80 and 70. I'll go 85. I'll go 84. I'll go 83. I'll go 82. I'll go 81. $76? What? Okay, but it works. This works. So you add this mutable stuff on top of here, and you go down. What if can you add more here? Can you do like print? Okay. You have to put both of them in curly braces. Print enter value bonds this thing, and would the chances reduce? I'm very, very curious if the chances would reduce if that's what I did. Oh, okay. If the chances aren't reducing, so you could kind of cheat it. Oh, so instead of we'll do chances -1 and continue. So this is much more reasonable. If I put this, it will do that, and it reduce. That's good. What else can I do here? I want to put, like, see, when you run that and you go like, let's say 50 for example, you said you guessed 50, this thing is too small. I want a space between each of these. So it should be the same between languages. So it should be something like /n. It's not working. Oh, okay. It's same thing here. It should be /n here too. There it is. There it is. There it is. So let's see, 50. Too small. 60. Too small. 70. Too small. 80. Too small. 90. Too big. 85. Too big. 84. Too big. 83. 82. There it is. Okay, that's good. That's good. So curly braces here. Can this be any value? Like, let's say if I put I, for example, and put I over here, it can be any value. That's fine. This chapter covers concepts that appear in almost any programming language and how they work in well. Okay, I think I'm going to rest a bit. I need to get some food. I need to buy some food. So, yeah. Ending stream.